Good morning. Today we are going to be starting a new topic called solving equations. But before we dive into that, I want you to consider this scale that I've drawn here. Now, it's also called a balance. Now, on this left-hand side of the scale, I've got two big weights, which I've labeled X, and then two smaller weights, which I'm going to say are 1 kilogram each. So on this left-hand side of the scale, I've got two big weights called X and two 1 kilogram weights. And on this right side of the scale, I've got 1, 2, 3, 4, 5, 6 1 kilogram weights. So, and this scale, or this balance, is balanced, which means that the left-hand side of the balance weighs the same as the right-hand side. Okay? Now, I want you to tell me how much this X weighs. How many kilograms does one of these X weights weigh? So have a think about that. Okay, so I'll tell you how you can do it. The first thing is we want these big X weights on their own. So the way that we can do that is we remove these two smaller 1 kilogram weights. But in order for if we just did that, the scale would be imbalanced. The left-hand side would no longer weigh the same as the right-hand side. So what we need to do is we need to also take away 2 kilogram weights from the right-hand side, and in that way the scale remains balanced. Okay, and so now we have that 2 of these big X weights weighs the same as 4 of these 1 kilogram weights. So in other words, we've got 2x equals 4. We've got our balance here. And in order to, we want just x on its own. Okay, and so what we're going to do here is we need to divide by 2. Divide by 2 on both sides. So 2x divided by 2 is x, and 4 divided by 2 is 2. Now, of course, we could just easily see that, and I'm sure many of you could see this in your heads, that one of these big X weights was had a weight of 2 kilograms. But what I want to do in this lesson is to set up a way of working that is going to allow us to solve much more complicated equations. So I'm sure that many of you have seen this before and will be able to do this, but it's very important that in what follows that you follow my methods and my explanations, and you write out your work exactly the way that I do, so that when we get onto harder and much more complicated problems, we're going to be able to do them really, really well. Okay? So, I'll just clear this canvas. So by the end of this module, what I'm expecting is for everyone to be able to solve really horrible looking equations like this. We're going to be able to solve really difficult equations like this, and the way that we're going to be able to do that is by following the methods and the notation that I'm about to show you now. Okay, so just keep that in mind. We're going to be able to solve all these types of equations using the methods and the notation. Extremely important. Okay, so let's start. Let's start with an example. So let's say I want you to solve the equation 2x plus 1 equals 7. Okay. Now the first step is to draw a balance or a scale. We're going to do this every time. Now we want to get our x's on our own, just like we did in the starter, just like we did on our balance. We want to get the x's on their own. And in order to do that, we're going to have to get rid of this plus 1. Now, here we're plussing 1, so to get rid of it, we're going to do the opposite, which is a minus 1. And we're going to write that, very important that you write that under the plus 1. Now, in order to keep the scale balanced, we're going to need to minus 1 from the right-hand side. So we're also going to write minus 1. And again, we're going to write that under the 7. Very important that you write that under the 7. So now we're going to do that. So on the right-hand side, on the left-hand side, we've gotten rid of this plus 1. So we're just left with 2x. And on the right-hand side, we've got 7 minus 1, and that's 6. Okay, but we want x on its own. So we're not quite done. We're going to draw in another scale. Here I've got 2x, and here I've got 6. So I've got 2x, so I need to divide by 2 to get x on its own. I'm going to write that under the 2x. I'm going to divide by 2 under the 6. I need to do the same to both sides. When I do that, 2x divided by 2 is just x, and 6 divided by 2, of course, is just 3. And that's my final answer. X equals 3. So I've just got x on its own equal to 3. Okay, let's have a look at another example. So, example 2. Let's solve 3x plus 6 equals minus 3. 3x plus 6 equals minus 3. So remember, we want, well, first off, let's draw the scale. Now, we want x on its own. That's what we're trying to get to, x on its own. So I'm going to get rid of this plus 6 so that we have the x's on one side and the numbers on the other side. So to get rid of the plus 6, I'm going to have to minus 6, and I'm going to write that under the plus 6. That's important to do. And I'm going to write minus 6 on the other side under the number minus 3 to keep it balanced. Now, I've got 3x on this side, so I've removed the plus 6, equals, and then minus 3 minus 6 is minus 9. Okay, I'm going to draw my balance. Now, you'll notice, and in the previous example as well, you'll notice that I've kept my equal signs lined up. And this is something that you should do also. Keep your equal signs and your balances all lined up. I should see a nice line of equal signs all down the page, okay? So now I've got 3x equals minus 9. Well, 3x, that's 3 times x. So I'm going to need to divide by 3 to get x on its own. And I'm going to have to divide by 3 on the right-hand side to keep it balanced. So 3x divided by 3 is just x. I've got my equal sign nice and lined up. And then minus 9 divided by 3. Well, remember that a negative number divided by a positive number is just a negative number. So the way that we do this is we just do 9 divided by 3, which is 3. And then because it's a negative number divided by a positive number, it's a negative. So I just put minus 3 there. So that's our final answer. X equals minus 3. Now let's have another look. Let's do one final example. Let's do example 3. Let's do 12 equals, let's get rid of this. 12 equals 3x minus 3. Now there's something different about this one, of course, isn't there? Here we have the x terms, the algebra, on the right-hand side of the equation. Previously, we've just had it on the left-hand side. Does it matter? Well, not really. Not really. We are still looking to get our x's on one side and our numbers on the other side, okay? So, first step, let's draw the scale. Now, we want our x's on one side and our numbers on the other. So, what I'm going to do is I'm going to get rid of this minus 3 by adding 3. And that means I need to add 3 to the other side, writing the numbers under the numbers. And when I do that, well, 12 plus 3 is 15. And then this, I've gotten rid of the minus 3, so it's just 3x. It doesn't matter that the 3x is now on the right-hand side when before we had it on the left-hand side. That's okay. Now, we're not done. We've got to draw in our scale again, keeping our equals nice and lined up. Now we've got 3x, so that's 3 times x, so we're going to have to divide by 3 to get x on its own. And then to keep it balanced, we're going to have to divide by 3 on this side as well. So equals 3x divided by 3, of course, it's just x, and 15 divided by 3 is 5. So we've got 5 equals x, or in other words, x equals 5. That's fine. You can leave your answer just like that. So at this time, I'd like you to pause the video and work through the first set of questions, and then we are going to be moving on to something a bit different. So pause the video here and go on to the next set of questions. I really want you to focus on getting the notation correct, because the notation is the most important thing here. Don't just write the answer. I know a lot of you will be able to do it in your head, but the notation and the method is what we're looking for here, okay? Okay, so hopefully you've done that now. And of course, if you get stuck, then go ahead and look back at the examples to check your work. But now we're going to be moving on to a slightly different type of equation. What if if I tell you to solve this equation? So we've got 8 equals x plus 5 divided by 4. So we've got a fraction. We've got 8 equals x plus 5, but then all of that is divided by 4. So what we're going to have to do is, again, as always, we're going to have to draw this balance. Now here, I've got x plus 5 divided by 4. To get rid of that divided by 4, I'm going to have to times by 4. And to keep it balanced, I'm also going to have to times by 4 on the right-hand side, on the left-hand side. So we've got 8 times 4, which is just 32. And on this side, x plus 5, we've gotten rid of the divide by 4, so we're just left with x plus 5. And then, of course, we can just solve this like we were doing before. So I want to get x on its own. Draw it in my scale. Well, to get x on its own, I want to get rid of this plus 5. So in order to do that, I need to minus 5, and I also need to minus 5 from the left-hand side to keep it balanced. So now I've got x on its own on the right-hand side, and on the left-hand side, I've got 32 minus 5, which is 27. So x equals to 27. Let's do another example like that. Let's solve this equation. So let's solve 2x plus 2 divided by 3 is equal to minus 2. Notice that we've got the fraction on the other side of the equation now. It really doesn't matter. Okay, so the first step is to draw the balance. Now we're going to want to get rid of this fraction. So this fraction means divide by 3. So what we're going to have to do to get rid of that is times by 3. And of course, we all know by now we're going to have to do that to the other side. So on the left-hand side, I've gotten rid of the divide by 3, so I'm just left with 2x plus 2. And then minus 2 times 3, well, a negative times a positive is a negative. So we get minus 6. Now we can solve this just like normal. So I'm going to draw it in my scale. I want to get the x on its own. So here I've got minus 2. Do the same to the other side. So now I've got 2x is equal to minus 6 minus 2 is minus 8. And then finally, I need to divide both sides by 2. And I get x is equal to minus 4. Okay. So now that I've done a couple of examples, have a go at doing the next set of questions, and just pause the video here and make sure that you're doing the notation just as I do it. And if you get stuck, go back in the video and pause and look at the examples. Okay. Okay, so to finish off the lesson, I want you to have a think about what do I do if there is a negative in front of the x. So I've got 10 minus 3x is equal to 1. What do I do here? We have only been dealing with when there's a positive number of x's, but here we've got minus 3x. So how can I deal with that? I want you to have a think, maybe pause the video, have a think how you would deal with that, and then I'm going to show you how. Okay, so the first thing, I don't want to deal with this minus. I would much rather turn it into a plus, but there's a way that I have to do that. So I'm going to draw in my scale. And then, so I've got this minus 3x here. I want to get rid of that. And what I'm going to have to do is I'm going to have to plus 3x. So that cancels with the minus 3x, and I'm left with nothing here. But in order to keep it balanced, I'm going to have to add 3x on the other side. But you'll notice I haven't written that under the 1. It's very important that you don't write plus 3x under the 1. Like for instance here, don't write plus 3x under the 1. Okay, we need to keep our algebra and our numbers separate. So it's just plus 3x is not under the 1. Okay, now if I've gotten rid of the what am I left with then? So I've gotten rid of the minus 3x on this side, and I'm just left with 10. And on this right hand side, I'm left with 1 and then an extra 3x. So you see I've turned this 10 minus 3x equals 1, and I've added 3x to both sides, and I've now turned it into 10 equals 1 plus 3x. Now I've got a positive number in front of the x, and that's what I want. We know how to do that. We've just been doing that this whole lesson. So I'm drawing my scale. I want x on its own, so I'm going to take away this minus 1. So take away that 1. 10 minus 1 is 9. On the right hand side, I'm just left with 3x. So I divide by 3, both sides, and finally I'm left with 3 equals x, or x equals 3. And so that's how we can deal with negative numbers in front of the x. We can just make them positive by adding that amount of x to both sides. That's all we've done here. We've seen that we have this minus 3x. We don't want a minus, so we've added 3x to get rid of it, but we've added 3x to the other side, and here it is. Okay. Well, that concludes the lesson. Thank you very much.